Can you hear me if I don't? Can you can hear me? Can I be heard in the Teams without a mic? Yeah. Okay. All right. Sige. All right. So good afternoon, everyone. Magandang hapon po. And in French, that would be and welcome po to the Benthic Habitat Mapping Practical Training, day one. Okay, so this is a 2 day, well, the training is duplicated over 2 days. Thank you for joining us for day one. Okay. So just some housekeeping rules. Well, these rules are more applicable online, but the spirit of them still apply. Please participate as much as you can. If you have any questions, feel free just to raise your hand. When you do ask a question or even give insight, please introduce yourself at least the first few times. We're such a small group, and I think it would help our discussions to know how we should call you and also what institution you're from. So we have sort of a little bit of context. Okay. But yeah, any questions, concerns, just raise your hand, and I'm sure Anlo, our facilitator, will address it. Okay. So before we move to the training, just a brief background on Copernicus or CopPhil program specifically. So CopPhil, or the National Copernicus Capacity Program in the Philippines, is a flagship initiative by the European Union through their Global Gateway strategy. It's currently being, or part of it is being implemented by the European Space Agency in partnership with their strategic partners here in the Philippines, one of which is the Philippine Space Agency, which is why we are grateful for them letting us use their facilities while they are out in team building. And also the Department of Science and Technology. I'm Monica. I'm with Indra Philippines, which is a private company here in the Philippines, headquartered in Madrid. And we focus on, well, I focus on more the IT side, but we also have defense, space, and transportation in Spain. So all of us are part of a consortium of private institutions and some academic institutions that have been contracted by ESA to implement certain components of CopPhil, in which, in our case, it's the pilot services. But more on that, or more on what the EU has in store in terms of a strategy for CopPhil, let's hear from the ambassador to the Philippines from the EU.
European Union is not just a political and economic. It is much more. It is a global partner which values cooperation, inclusivity, human rights. Here in the Philippines, the European Union has been a reliable and consistent partner for over 6 decades. We support a very wide range of initiatives, from promoting peace, good governance, human rights, to enhancing common security in a complex geopolitical context, advancing digital innovation, trade, disaster risk reduction, green economy, and much more. This long-standing partnership reflects our deep commitment to working hand in hand with the Philippines in building a more sustainable, resilient, and inclusive future where no one is left behind. In the Philippines, a country especially prone to hazards and the consequences of climate change, this means supporting initiatives which create real opportunities for communities, foster innovation, build resilience in face of these global challenges. And in this context, the Philippines stands to benefit immensely from the integration of Earth observation technologies. This will strengthen the country's capacity to address climate and hazard-related vulnerabilities and will support biodiversity conservation. I am very proud, therefore, to introduce CopPhil. CopPhil is a unique flagship initiative of the European Union Global Gateway Strategy. It is managed by our team here at the European Union delegation, and it is implemented by the European Space Agency in partnership with the Philippine Space Agency and the Philippine Department of Science and Technology. CopPhil promotes the use of free and open satellite data from Copernicus, the EU Space Program's Earth observation component, through activities including the establishment of an IT infrastructure and Copernicus mirror site for accessing and processing Copernicus satellite data on biodiversity, on forest management, on agriculture, for example. This transfer of data is reinforced by the CopPhil training program, for which we are very excited to cooperate with institutions across the Philippines. These courses build a shared understanding of value and the practical applications of Copernicus satellite data. Together, through CopPhil, we are advancing a partnership which empowers the Philippines to become a central hub for Earth observation in Southeast Asia and supporting its path towards a more sustainable and resilient future. I would like to sincerely thank all of you, the participants, as well as our partners and stakeholders who have made this training possible. Your dedication, your enthusiasm are the foundation of the CopPhil success, which is a very important joint initiative together with our Philippines counterparts. Let's remember that our progress relies on ongoing cooperation, shared learning, mutual support. The challenges in front of us are complex, this we are very aware, but it is united in purpose that we can build lasting solutions. Thank you very much.
Okay, so today you are in part 2 of a 3-part series plus a part 0. Our training series started with an introductory course to CopPhil in general and remote sensing in general. Prior to part 2, we had the theoretical courses, and then after this course, once you've completed it, you will then be eligible to be invited to our application course or application workshop to be scheduled in August to the lead up to Philippine Space Week. So Philippine Space Week is from August 8 to 14. So the week or 2 weeks prior to that, we will be conducting our application workshop. Okay. So each one of the services that we are currently making has its own set of training. So today is the Benthic. We also have ground motion service, land cover service, forest service, crop service. Okay, and all of these are accessible via our CopPhil digital campus. So you can scan the QR or go to that link, and we do encourage you to create a free account. So it's completely free, because through that account you're going to be able to get your official certificate for today's training. Okay, and also if you take the previous courses and join us for the application courses or the application course, you're eligible to get the official certificate for the entire training series. Okay, and you're not limited by Benthic. Again, if you're interested in the other services, they're also going to be available on the site. So yeah, just make your account. You'll see the different fundamentals. This training will also be uploaded there for your reference in the future if you want to go back. Yeah, this just shows where you can get your certificate of participation and then your attendance. Okay. Before I give the floor to Anne-Lord, are there any questions, concerns? Okay, if not, I think they're ready for you, Anne-Lord.
Thank you, Wanda. Hello everyone. So we're really a small group.
So, but it's not bad because what I'm going to propose to you is really a participation training courses. So if you have questions, if there is something you would like me to repeat, if there is something that is not working, you just ask me, you interrupt me. We take the time for you to be sure that you have all the steps working. The big plan at the end of today is for you to be able to run your own bathymetry maps from A to Z without any support or help from us or anyone else, okay? So really, if you are stuck somewhere, if you don't understand, please just interrupt me. I mean, don't be shy. There is really the room for that. Yes. So the plan is to have two big steps today. So we're going to first start with how to download the Copernicus data, how to retrieve the data that absolutely you need and not something else, to focus exactly the area that you're looking for or the temporal that you're looking for. We're going to then working a bit with QGIS, just basic manipulation and exercise for you to be comfortable manipulating the data. After the break, we go directly to the bathymetry module and how to run the bathymetry on an interface web service, and also how to perform the calibration, because the calibration for the bathymetry is really the main step that will ensure the quality of your final product. So let's start with the Sentinel-EO mission. So the data are accessible from the Copernicus hub. So I encourage you right now to see, because we're not a lot of people, so we could all download the data from the Copernicus hub, or at least if you can open the web page to see the different options that I'm showing you and how it works if you try to change the date or if you try to draw a polygon for your area of interest. So the website that you need to type is Copernicus Hub. And then you have a web page that appears, and you should click on browsers. You should all have already accounts there. And if you don't have any accounts, then we can have an example to show. So I'm just going to change my screen. So Copernicus Hub. Copernicus browsers. Can you all follow at the same time? Yeah? It's a bit slow, so I don't know if we're going to be able to download, but you should have the data already on the data set, on the data folder that you had to download prior to the courses. Let's see if I can display. All right, doesn't look so. Okay, no problem. We're going to use this one. So once you created your account on Copernicus Browser, you should be able to have something like this. So here you have the login. Sometimes you need to relog if it's too much time has spent. So your account is automatically disconnected. Here you have the possibility to select a single date or a temporal range. So here on single date, you have a little calendar that open. You can select the date exactly that you want. Or if you would like to have a selection, you can already also have asking for a temporal range. It is going to show you all the data available between your start and your end date. Then you have also the possibility, when you do the search, to navigate through the map and to draw a polygon around your area of interest. And once you have date and area of interest, you could also specify the type of Sentinel-2 data that you want. So there is 3 satellites currently providing data for Sentinel-2, A, B, and C. But be reassured that the A, B, and C are exactly providing the same type of data. So usually we don't discriminate by type of satellite, but by level of data, because for these courses, we're going to work with bottom of atmosphere reflectances, so level 2 data. You managed to have the Copernicus Hub open? Yes? You have the Gara, you see how you can navigate? I'll just select, for example, some dates. So let's take 5 minutes if you want to see how it works, if you have any questions. If you don't have an account created, it's okay. You can retrieve the data on the SharePoint that has been shared with you through the course. If you want to select, for example, a range between start date and end date, and you don't even define. Yeah,
Usually I just do the configurates, then look at the available in
place it. Yeah. So that will be around visualize. Any question on the data retrieval site?
used to be Sentinel Hub.
It used to be Sentinel Hub, yeah. They made an update, I think it was 6 months ago, where they changed everything. But when you had an account on Sentinel Hub, it was automatically transferred on the Copernicus. So you didn't lose anything there. Some say that Copernicus browser is a bit easier to use, but it's true. If you've been used to work with Sentinel Hub, the change could be surprising a bit, but yeah. All good with Copernicus Hub? Yes? So once you downloaded the data, this is the type of file that you obtain. So Sentinel-2 data are always provided in zip that you can unzip and obtain then a safe file. So the safe file, .safe, is the unit data for Sentinel-2. Okay, if you unzip sometimes, you have another folder where inside you have your safe. Be careful, the real data is a .safe, not the prior folder. So how the Sentinel-2 data is organized, already in the name, you can find a lot of information. And usually when we code some function to work with Sentinel-2 data, we rely on this information to fetch the parts that are interesting for us. So quickly how it's organized. The first part is the satellite that the data is coming from. I told you that we have 3 satellites currently acquiring data. So Sentinel-2A, it means that the satellite Sentinel-2A acquires the data. You can have 2A, 2B, 2C. Then we have the level of processing. Usually we propose 1C and 2A. So if you really want to know what happened between 1C and 2A, you have on ESA website and Copernicus website the user manual and the documentation regarding. But what's going to be important to remind us today, it will be 1C is above the atmosphere. So it's like the satellite is just running above the atmosphere, taking a picture, and this is what you're going to have. 2A is bottom of atmosphere. So we take the image provided in 1C, we do an atmospherical correction just to pretend that the satellite was running between the atmosphere and the Earth, which is absolutely not possible. So it's an algorithm modification. Then we have the date of the data take. So we combine the data take starting date with the acquisition date. So this satellite image has been acquired for February 11, 23. Okay. We have then the processing baseline number. Copernicus is always, and ESA is always improving the software to transform Sentinel 1C to 2A or to improve the quality, the core registration. So this processing number is giving you the level of the processor that has been used. So usually the bigger number here is better because you know that you have the last update of the pre-processing data. Here it's a relative orbit number that can be useful, for example, when you're trying to map larger areas, so you can regroup the different orbit numbers together. And the time number ID will be quite interesting for us because it's going to be the most local unit information we're going to have. So we know that 50 PRU is about Fullion area, for example. And then we have the product discriminator. Usually it's the processing date. So usually when ESA is acquiring the data from the satellites, the processing is already happening a few days later. But when we have a new processing algorithm that is out, ESA is providing a reprocessing of all the data. So the date here will change. So you could have several Sentinel-2 level 2A 11 February data, but only one that have been reprocessed in 2024 because of the last update of the processor. All right? So now let's see what we have inside the safe folder. So the tile ID, that could be interesting, yeah. So the tile ID, the old Earth, has been covered by ESA, and each little square has a specific and unique tile ID. So that is a great discrimination. If you're looking for a specific area, the tile number ID will give you one location. So if we do a little zoom, this is the tile we're going to start working on the first part of the course. So you can already retrieve it and be sure that you have the PVP, which one I said we have PVP data on your laptop. So what we have inside the safe. So inside the safe file, you have multiple folders and some XML and safe file. So the Inspire is a universal metadata structure file. So when you have, for example, a software that needs to run over several different imagery, from Sentinel-2, from Landsat, from Worldview, they all should be Inspire compliant. And so we know that a reader for Inspire will be compatible for multiple data take. But you don't have all the information in Inspire. So that's why you have the MTD level 2A, which is a metadata that is specific for the product that you have downloaded. And then the manifest is just general information about the orbit, about the satellite acquisition. You also have some calibration metric there. So what is a data stripe? So we saw that the acquisition date was the data stripe acquisition date. So we know that the tile is the smallest unit that you can have, and the tile, the data stripe, and the data take are different. So it's depending on how Sentinel-2 is acquiring and sending back the data. So this is, for example, a data take. So the satellite is getting a whole path around the Earth all together. It doesn't take some individual picture. It's getting a whole path together. But that is really, really big. We cannot download all those in one go. So we have several antennas around the Earth. And the antenna, for example, the first antenna here, from the data take, I'm going to just download this data stripe. Okay? So we separate it in downloading section for each antenna to be able to download it. Like that, we always have space on the satellite for the new data that are coming, and we don't overcharge the different data center and ground segment to do the processing and providing the data directly. What is really important and what we're going to work with today is the granule folder. So in the granule folder, you have several subfolder until you have access to the tile itself. And it's all organized by band. So in EMG data, you have the band at 10-meter resolution, 20-meter resolution, and 60-meter resolution. Inside, you can see that you have, for example, B02, 10 meter. So B02 for Sentinel-2, what color is it? Do you know? Yes, blue. So here we have the main usual bands. So blue, red, blue, green, red, and infrared. So it's not like a picture that you take with your phone, where when you take a picture on your phone, you already have a true color RGB image, because it's taking everything at once. Here on the satellite, you have different cameras that are specialized in different bandwidths. So you can separate all the band. If we take, for example, the 20-meter file, you're going to see that we have some duplicates. We have 2, 3, 4, and 8 again, but we have additional ones. We have 1, 2, 5, 6, 7, 11, and 12. So those ones are also very, very useful, but less common. And usually they are using, for example, for larger area analysis. So having 20 meters is usually enough for what we want to do. But let's be aware that if you need, for example, band 6 at 10 meters, using the band in this folder, you can find some correlation to do the downsizing of your data. So thanks to the correlation between the different bands at the different resolution, you can easily provide and get the resolution that you need. And same for 60 meters. So 60 meters is all the bands that are available that you can have access to. Hop. This is, yeah, so this is the comparison between the different bands that we can have. And 60 meters, you see that we have a longer list. So the Sentinel file, the bands are provided. You can see that it's GP2, so it means GP2000. It's a type of compression of the file because otherwise, if every band is stored in raster, it's going to be too big to be downloaded, manipulated. So GP2000 is a compressed raster file type. If you have some Python script that have directly a reader for the Sentinel2 data, usually you need a specific reader to GP2000 to access the pixel information. While when you save it in GeoTIFF, it's saved line by line of pixel, so you can directly access the information. So in GP2000, be aware that you might need extra decompression steps. And what it looks like. So this is the file we're going to work with, so PRU. So here it's band 2. And the band, even if it's the blue band, it's not in blue. The information is in a grayscale. And when we click on a pixel, we have the value of this pixel. And this value is giving you the information of how many blue information is sent back to the satellite in comparison to the blue information sent by the sun. Okay? So it's what we can retrieve. So if we have a practical exercise, this is an RGB view of North William. And I have retrieved for the same pixel the information in blue, green, red, and here. And we can see that the green information is higher than blue and red, which is why we can see the pixel in green. Because it's vegetation, the near band is the one that sends the most information back to satellites. That's why for NDVI, we're using the near band version. And we can correlate this with the reflected spectrum of vegetation. We can see that in green, we have a little spike, so it's the bigger information. But in near infrared, this is where we have the most information that is sent back to the satellite, and this is why it's 5 times bigger here. So all the information that we get from the satellite can be linked with a physical property that you have on the ground. So how we can use this physical property, I invite you to all open your QGIS. And we're going to do some little raster manipulation with the Sentinel-2 tile T50PRU that you should have already downloaded. Do you already have the 50PRU? Yes, all good? So we're going to work together and build a 0-1 NDVI mask. And then I'm going to propose you 2 other exercises that you're going to be able to choose and build your own mask based on what we're going to see now. Okay? So let's go. We're going to download the image you have. Open the image on QGIS. Then we're going to build the NDVI mask. And from the NDVI image, we're going to create a mask based on the threshold and vectorize it to have a shapefile. So how to open an image on QGIS? Do you all know how to open an RGB image and to merge the bands on QGIS? So if you open your QGIS, the first thing you go is to do the raster option. I can't pronounce that word in English, sorry. But that's divers tools. And you go on merge. Okay, we all there? Can you all open the merge window? No. I didn't have the... okay, it's open there. So you all should have this window open. So here you go on the 3 dots there. And you have another window open and you need to select files. Oh, what's going on? Oh no. Yeah, it's gonna be open. You didn't test it before. This is probably why it's supposed. My voice will not verify this app is free of malware. You cannot force the opening. You downloaded the one before Mac, right? Can you prove with one of the two like that you can follow the different steps for QGIS?
Let's take note.
Yeah. And try to make all the configuration. So you have the merge opened. So on the three dots, and you go to add file. And now you're going to search the band 2, 3, 4, and 8 in the files. No, that's the data zip. You need to open that. You need to dezip the file first. You just need to select the GB2000. So you go on data. So which one we are working on? Yeah, we guess. And then we saw the bands are in rectangle, yes. Page, yes. And we want 10 meters, and you select image. 10 meters, yeah. And you select band 2, 3, 4, and 8. You haven't need to see. Je vais changer le. Là, vous êtes stop de. Je sais pas pourquoi il. Ah, c'est bon. J'aime. You have them? On 10, yes, open it. And you select. So the GP2, be careful, that's the ox. So 2, 8, 3, and you need one more. 2. Yeah. And if I open. Yeah.
1, 2.
You have them at the display here, so you can check you have 4 bands and you click OK. And we wait for everybody to join us. Okay? Hey, oh. You wait for rest.
Okay.
Okay, so we all have the 4. And 2. Yeah, brilliant. So, of course, we need to place each band in a separate. If you don't tick that box, QGIS is going to average all the data per pixel, and you're just going to have one result that is a cooking mix of all the values that you have per pixel. Here we want to have a multi-band raster, and each band going to be the band that you have selected. We want to save the merge in a folder, so just save it on the 3 dots. You can select the saving part of your file and name it something easy for you to remember, the date, the time that you're looking at, and which band do you have. Usually like that in one go, you know what your tip is. And we want to open the output after running for it to be directly downloaded on QGIS. Let me know when it's saved. Sometimes the saving can take a bit of time because it's heavy files. All good?
Click on run.
Yeah. So run is to execute the command. Because QGIS, it's an interface, but behind that, it's Python script. So that's why you can find some code. So run the Python script. And you can see in your little box, GDR. So this is the command line that's going to be sent in the Python background to execute. You all managed to run? Oh, process, GDR, things just gone. Do you have a problem when you install it? You didn't install the package.
Oh,
Down here. So cancel. And we're going to try those. Try raster. In execution. And in virtual raster. Try with this one. Same process. And you don't have to save anything. Okay, it's going to be in the virtual raster. That should help. Running for you? So algorithm merge is finished. You see it's open the band, so you can close the window. Up. It's finished running. You can close it. All good for you? Aha. So I can put on your raster. Don't save anything. Cancel. Don't save anything. Just keep it this way, right? So you see, it's a virtual raster. So this file doesn't exist on your laptop. It's QGIS in its memory. Say, okay, I can give you some space, and you can work with it. You can close. So now you should all have your virtual raster, right? So what is my next slide? Ah, yes. So if your merge works properly, you don't see this, right? Why don't you see the same picture than me? In your guess?
It's more red.
Yes. So we know that band 2 is blue, 3 and 4
Here.
red.
Oh, yeah.
So you're all gonna double click on your picture image, double click, no, on the raster directly. Those, and on the raster, yes, double click here. Yes, symbology. What can you see in red band? Yes.
Green is in the woods. Green is.
No. Green is 2 and blue is
1.
yes.
So you're supposed to change.
You need to change it because the way QGIS have stored the band is the first one as band 1. But you know that you in red, it's actually your band 3. Okay? So you should have 3, 2, 1. Okay? And if you apply, you should see an RGB.
Yes.
We all good?
Yes.
Ah, I see a real face. Wow, thanks. So 3, 2, 1, yes, okay. Oh,
There's a gray.
yeah. What have you merged? Your error. Aha. You have all the statistics English. That's weird. So you made a save, right? Then I'll try to reload the image. Ah, drive to the left. You have a band that has been cancelled. You don't have any blue. Yeah, you don't have any. Try to redo the merge, okay? And if it doesn't work, you can throw it in. Okay, so you all have your band, your raster band together. So now we're going to build the NDVI mask, okay? So to build the NDVI mask, we're going to ask QGIS to do some calculation with the band. So we go back on raster, the same menu that you had for the merge, and we select the first one, raster calculator. You all have it? So the equation for the NDVI is a band ratio between the red and the infrared. Okay, red minus infrared. Don't know what happened there. Oh yeah, no, it's okay, it's done. I read too fast. So infrared band minus red, okay? So how are we going to translate that inside the calculator? So you, in the calculator, you should have the list of all the bands that you have, okay? So be careful, band 1 is the one that you have selected, right? Okay? So to build the equation, we need to say it's working pixel by pixel. So we need to provide for each pixel what to apply, okay? And what we want is, for each pixel, take the band 4, do the subtraction with band 3, and then make the ratio with the addition of the 2, okay? Do you understand the equation? What is your question? Don't be shy, we're all small here group. So what is the question? So you have the different bands, 1, 2, 3, and which one here is the red and which one is the infrared? So 3 is your red and 4 is your infrared, okay? So now be careful because you're doing an equation. So if you want, write it in the paper first. Where are your parentheses? Where are your ratio bar, okay? Be careful of the parentheses. It's like in mathematics.
Still the same.
You try to show ratio 3?
Yeah.
What can I have in the So let's see band 1. Okay. This is a problem. You don't have any band 1. Why you don't have any band 1? Band 1 you have. I don't have any problem. You shouldn't have any issue with that.
Okay, example installation. You have a problem with installation.
So you should have all that, okay? Do you have them all?
Raster.
So you see you have them. So even if you have some issue in the display, because maybe when you did your install, you haven't installed all the packages, you should be able to follow the rest of the exercise. Okay, so try to build your MTVI raster and we're going to compare if it's the good one. Okay? You have your equation?
Yes.
Can I check? Picture 4 minus 3? Yes. You can output the layer and run it. Where are we? Yes. You can put the output and run it. Select the name, so be careful, it's the NTVI here that we created. You have an error? Ooh, you have something here. So on this, these are great steps because we have only one band. We always have NTVI. We don't have multiple bands. You can check, remember, job of the list, you can check the number of bands that you have. You should have one. And so this one is just NTVI. So you can apply some color if you want. Here, single gray, you want single color. Yes. No, you need first to select the color. I'm on the other side, so if you color map. You see to select what type of color that you want. So NTVI is for green, so I would suggest greens, make more sense. So do you know NTVI value when it's close to 1? Is it vegetation or is it not vegetation? So when it's close to 1, it's vegetation. Okay, so here you know, apply. And you should have something really like that. Be good?
Yeah.
You have your band? Apply yes. It's working with you with the. All good?
Yeah. color.
So you select what you want. Here you in gray. Here it's one color, one band, but with some colors. So yes, single band colors. No, right. Yeah. And here you can select the color map that you want to apply.
Okay.
It's working? Okay.
So,
So color map. Here. You can select which one you want. Yeah, and you see it's automatically calculated.
can I change the value of the yes?
Yes. But be careful, NDVI it's a ratio, so it's go between -1 and 1.
Okay.
We all have our NDVI, but the point is to make a mask, right? So how are we gonna, from this one, get just the NDVI that match the vegetation? So we're gonna build a mask, okay? And so I've done some tests for you. What we want is NDVI that is above which value I select 0.5, okay? So we're gonna go back to the raster calculation because we want to create a new raster that is a manipulation from the NDVI, okay? But the equation is gonna be a bit more tricky. I don't have a table, but yeah. So for each raster, you have a pixel that is characterized by a function of its bands, okay? In our case, it's the NDVI, the ratio between band 1 and band, so band 2 and band 3 and 4, sorry, okay? So what manipulation we need to do to calculate our NDVI? So here, let me go through the equation with you before you type it. Here, what I'm doing in the first part, I'm taking all the NDVI value that are above 0.5, and I put the value 1 for them, okay? I multiply it by 1. So all those values above 0.5 will be equal to 1 in my new raster. And addition, because I need to take all the pixels above 0.5 plus the one below, so that's why here it's an addition. The raster below 0.5, and I want that to 0, okay? If here I'm saying equal, it's because I want to have all the pixels considered, okay? If you forget one, here you just strict and strict, all the pixels that are at 0.5 will not be considered, okay? So try to build your equation, and remember, we need all the pixels, so that's why we're considering everything. And my multiplication here is to set the value of this condition. If you do some Python coding, this is my if, and the condition have to apply if the case is being fulfilled. You see? Okay, let's try to build the equation for the NDVI mask. Yes.
The value, not with the size. Because when you look at the equation, yeah, if you want the value to keep, don't listen, that's the exact way. If you want to keep the value, you put the line by the rest of the line. That's for each seconds, the program we are trying to be clear.
In the
No. This is how the if is being tested. If for different places in multiple raster, you should.
Okay.
Yeah, it's the tricky part. That's why I have my calculation. The raster calculator is always tricky when we deal with places where you need the same raster.
Do you have?
How will we determine if the raster band is like 0.5 or less than 0.5?
So that is the threshold 0.5 is something that I selected for you, okay? Because this is not the objective of the course, it's a vegetation, you give that for vegetation people, right? But the 0.5 is set by some analysis. When people are working with NDVI, they decided that 0.5 usually is to gather all the vegetation, okay?
First one is in the
Aha! So you have those mistakes. And I check. You don't have enough to have. So where are we?
and maybe I don't.
No, it doesn't. It doesn't. So this is because you inverted, instead of doing near minus red, You've done red minus here, okay? So for you, it should be the opposite. When I say above 0.5, you need to put below, okay? Because for you, all the strongest value are not vegetation. See, vegetation is really low.
Yes.
That's the between there. Yeah, you check on Instagram, no? You have all your value between 0, 2, and 2. But yeah, maybe it's just between. Let's see. Okay, let's try to do the conservative 0.5. Okay? You want me to test the equation again? You want to retry maybe the equation. Remove this one and try the equation in the right order. You have it?
Yeah.
So check with these two, the black pixel should be either the 1 and the rest should be 0. We have it?
It's like.
No, this one is wrong. Oh, no, wait. No, it's okay. It's okay. Sorry. It's different from my laptop. But here you have equal again. Here it's strict because you don't want 0.5 to be considered twice, right? So it's strict here. And your way is invalid. Yeah, you have two in parentheses. This one remove, the external one you remove.
Yeah, minus.
And it's still invalid?
Near is
Fine. Over.
near minus. Near with the. Aces.
No, you don't have any space. Because the multiply, you haven't choose multiply from the tool. For all the operator, you need to use the operator here. It's QGIS interface, yeah.
Oh,
Pretty good?
yes, yes. Okay. Still back to. Oh, yeah, thank you. It's not.
Which QGIS are we for? Versus Lara, when you open it, say yes, it's last. Here. We good?
Yes.
Oh, where is your NDVI? You're on 0.
This one.
I understand. I think I understand. The land should be there, right? There's a problem. You go to 0 to 0. So yeah, there is a problem in your master test. I'm done the same mistake that the others. Yeah. I know you're yeah. So you see the vegetation is very nice. So that means that you've done the opposite. Instead of doing linear minus red, you've done red minus linear. Okay? So you can reduce the equation. And instead of having above 0.5, you say strictly or equal below. Okay? You want you need to be very good. Okay. More and your vegetation is below 0.5.
Okay.
And so probably the same issue for you. Try to have 1% of the instruction.
And I know there's so.
It's probably the instruction no, because you have the same data. You all have downloaded the same data. So probably the problem with the QGIS. The problem I have is they have the same issue on the other side. So I don't know I don't understand that issue. Open home issue making a problem with this one.
I'm very sure it's annoying. You
And you didn't tell me.
3.34 yung parang before but it's
So yeah, that should be a problem with your QGIS.
3.40.
40.
Yeah.
Yeah, so that should be the right.
Okay. How did you do?
So this is just that everything I need to calculate it, and this is the mass.
Yeah.
So this one is the same.
But how
So here is so you by default, your QGIS is taking the mean and the max and stretching the colors. But here I ask, and with this tool, I ask to recolor the image with just the view. So you go to views, toolbars, and you have raster. Yes. Okay. Is to stretch the histogram. So we're just going to quickly finish this one because apparently I have issue with your QGIS version. And then we're going to see, okay? So what you can do with your mask to still have something with the mask that you have here. Let me check vegetation is at which value. So this tool here gives you the value of the pixel. 0, 1, 0, 1, minus 0, 1. Okay, try to do the equation for the NDVI, okay? But instead of 0.5, you want the pixels that are below. Below minus 0, 1. Let's see, because it's English from already you have a problem in LGB. Okay. So try to make a filter there, okay? And instead of asking for the pixel above 0.5, you want everything that is below minus 0.1. Okay, try this way. And you should have it. And then we're going to switch directly to the bathymetry. I redo it. Yeah. We match that ends the line. It's true. It just says, I want everything that is below when you go to the minus 0.1. You want that 0 by 1 first. Yes. Everything that is below minus 0.1. You know that multiplied by 0. Mystery. How does it work for you?
Mine doesn't have lines appearing.
So what is calculating for you?
Like it remains at 0.
Because it's not being multiplied.
You
You see, it's not visible. Usually, so you and you color. It's working there. It's working with these thresholds. So you've done the threshold, maybe. Yeah. That's working there. We want this one.
Then also you want one long
This one, everything that is below we go to minus. And you know what the minus before? But we should put the value together. Remember it was minus 0.1. And you can do the same, minus 0. What is that? Okay. We multiply by
1. So, wala akong kitang.
I'll let you continue the equation.
So
So you do exactly the same, but instead of 0, 1, it's minus 0, 1. Okay, so remember to check the value. You see validation is minus 0, 1, minus 0, 2. Okay? So we have answer.
Yeah.
So you have the definition at 1.
Yes.
Always find a solution.
So anyone will be.
This is because the LDP identity.
So I don't know why there is some value when you open the image, you have some of your values that has been shifted, the same here. But you don't have all the same data, you all have the same PGN variance, so I don't know if it's the way you opened it, yeah, I don't know. Yeah, what happened when you opened it? The point is that you have the last.
Ready to form a investigation. One, really got like some time with it. Because you want something. Spring on stuff. They said, you know, significantly, we even have better than class. They just have been thinking that they try to get. As for the high version, some countries, but do nothing. Better than as the conclusions.
So there is some.
Bye.
That's okay. You see, your 1 is white, so your 1 is your vegetation. You just have the invert here. And you have nothing at all.
Yes, I did.
What have you done?
I don't know. Okay.
Yeah, remove a layer and try to also remove from your find folder. Maybe find there is a problem in the overwriting.
Okay.
We good?
Yes.
Okay. So we're going to continue. You just redo the equation.
Yes.
So now, as you see, we have a raster file. But when we working with processing and when we need to mask out files, usually what we need is a shape file, a vector file. So we're going to convert our raster into a vector file. So you go to raster, the tool, the option for raster calculation, raster options, and you do a conversion this time. Okay? And you want to polygonize, it means to transform a raster into a vector file. And you should have this window that opened. Yeah? Have it. Get you. Organize. So which, yes, is it this one?
Yes. This one. Oh, because
You have different outputs, so which one you need? So which one is your 1 and 0 mask? So you need new, okay. The band number is 1, okay. And you need to say here, or you can try with the temporary file, it's not a problem. Try to run this one. It's a problem with Cheetah. You manage to do with your equation. So minus 0, no, the parenthesis is here.
it can go on.
Which by 1, so that means I'm going to that. Same here. Parenthesis after minus 0, 1. And 0. Yes. You remove test 1 from your folder, right? Okay, try to remove it. And then white. Now, it should be done. Ah, no, here. We need here, 3 dots. Yeah, and now you type your test the right the way you want to say it. You go to type and then you do a full pass. That's why it's working like it. So your vectorization is working.
Yeah, I found an error and then look that should be file.
Yes, it should be right, yes.
And then because CopPhil is that was respond.
No.
You have permission to try and go back to parameters. Try to run on neutral again. No output lines. Okay? You try with no output lines.
Yes.
You try with no output lines.
I haven't.
So try with no output lines. It shouldn't be a problem for you. Here? No. Okay.
So I need,
You give it as temporary file, like your virtual browser, you're gonna have a virtual shape file. Okay? Conversion. Without push, okay, run. So it's the content organized that you don't have. So this is maybe when you're done the install, you have the old Chino package installed and this is the fact. You can have the various working and still in this area, yeah, probably this one's gonna work. No, it's more complex than that because you need to use everything together. So in your QGIS, you have two blocks and you need to check that you have the genomes block operated. So it should be in, yes, that's it, it's 30% of this. Yeah. And check that you have everything checked. Everything is to stage and vector drivers begins a vectorization. Sorted. It's the processing provided. So it's activated. Yeah. No, that's brass. Still working? Still running? Okay, so now you have here. We are almost at the end. It's okay. It's touch, okay. So it's okay. Here we have a whole tile that we try to build as a vector. So it requires a lot of memory for your laptop. So that's why it can be stuck, okay? Not a problem. It's okay. So here I'm just gonna follow. So we're just gonna see the next step together without even if your laptop is frozen. So you should have something like that, right? So you see it's all covered. Every pixel has been polygonized. If you click in one area, it will select the all connected vector or polygon, as we call it in ShapeFile. So once you have that, the only thing you have to do is by opening the attribute table, but maybe don't try. If you're already stuck with just the application, let's not close the problem, okay? But when you have a vector file, you have access to another type of function, because before we were working with raster file, now with vectors. On vector, each polygon has an attribute and has been recorded here. So in this file, I have 88,400 features. So that's why it's heavy, okay? But here you can see that this is the ID of my polygon, and this 0 here is the value it collects from the raster. So we know that all 0 are the 0 value on my raster. It was not, yeah? Yes. So 0 is not vegetation. So everything at 0, I remove it. Okay, so I can select everything at 0, all the polygons that have the value 0, I remove it. I only keep the one with the value 1. And I have, when I put the transparency, I see that my mask is covering all the vegetation. Okay? We can have a 5-minute short break before the bathymetry. Okay? So if you have any follow-up question on QGIS, for the following course, it would be nice if you have Spider that is installed, you have Spider. So you're going to be able to do the rest. Can you check if it's running, like not QGIS, Hello World or something to be sure that it's running? So you're going to need Spider and the code folder that you have downloaded from the link I share with you. Okay? If you have everything, and 5-minute breaks, and we meet at 20.
Okay, we ready to start? Yeah, all good? So to save some memory, if you want, you can close your QGIS. You shouldn't have any more use for this one. And if you want also, you can delete all the files that you have created to be sure that you have some space in your laptop if it's a bit tricky, okay? Let me know when it's all good. Ready? Yes? Okay, so now we're gonna see, so SDB is for satellite derived bathymetry. I'm gonna say bathymetry or SDB now, so don't be confused if I change the terms. So we're gonna see how the SDB module is working. So in terms of theory, how it's calculate the depth from the information that we give it, how to run the module from a web interface, so very user friendly. And the key point to obtain a good bathymetry is the calibration. So we're going to see how you can create your own data set to do a good bathymetry result, okay? So I'm going to give you the key in the presentation to do a good data set. So follow, focus. Why is it not working? I'll change my slide. Okay, so the SDB module that I'm going to present today, it's called the Send-to Coral module. So it's something that already exists, already been developed, used. We have publication paper that show how accurate it is. It's been applied for all the French Caribbean and some islands around Madagascar and some islands around India. So in theory, how we retrieve the depth from an image, we use the color, and for each color, we match a depth. So that is called an empirical model. So we're going to say for this color, this is a depth. In theory, in coastal water, we say that we can see up to 50 meters below the sea level, okay? In reality, when you have turbid water, because you have waves, because you have boats passing by, you have SPM, you have all those things, in reality, after 20 meters, it's really difficult to make the difference between what you have in suspension and the seabed, okay? So usually to avoid any inaccuracy and to maximize the performance of the algorithm, we stop at 20 meters, okay? So this is the in-situ data that we have. As you can see, it covers the whole area of interest, and we have data between 0 and 200 meters, because those data has been acquired on site with a boat. They have an eco sonar and they can detect directly the seabed. So we're not going to go to 100 meters. This data, we can, because all points, so points are vectors, okay? And we have the raster file below. So with each point, I can assign the color with a value of depth, all right? And this will help us to calibrate the model. So for bathymetry, we are not using all the bands, okay? The color that can penetrate the water, do you have any idea which band go inside the water? Blue, yes, that's why we see blue, so it's band 2. And the second best one is? Green. Yes, green. So that's why we're working with a log of B2 and B3. On the QGIS courses we had before, so you all work with masks. If you want to create a water land mask, one band could not penetrate water. Which one? No, the other one. Infrared. So on infrared, you can put a threshold, as we said, so -0.1 or -0.05, depending on your QGIS version. You can put a threshold, and everything below will be land, and everything above will be water. Usually, 0 is water. So B2 and B3 are the best one, and we are working with the log ratio of those bands. But to do the calibration, we have two coefficients that we need to set. How to choose those coefficients? This is the role of the calibration process, and this is why we need in situ data. So here, just for the fun, I took 5% random selection of the data. Okay, close my eyes, pick 5%. This is the calibration I have. Is it a good or a bad calibration? Yeah, because I have a very bad accuracy, right? And when the blue one should follow the red line. So 5% of all the data, very bad calibration. So I know that my M0 and my M1 are not the good one for bathymetry retrieval, okay? So we can do some tests. So I select randomly, always, 5 to 60, and we see that we manage to stabilize a bit the calibration, okay? But I still have an RMSE at 14. Not good enough. All the points are between 200 and 0. Instead of saying I've taken 5% of everything, how can I cut the point to do bathymetry? I know that my image, on my satellite image, I cannot see after 20 meters. So calibrating with points after 20, the algorithm cannot recognize the match, okay? Because for him, it's just water. So a solution is to say, I'm just using, so that was a slide, to select only the points that are between 0 and 20, okay? And you can see that when I do my random selection now, I have a much more stabilized RMSE, okay? So now that we know how to select the points, we're going to run the algorithm, okay? So you should all have the link. So you should all have the code folder, right? So I invite you to open Spider, and we're going to use Spider to run the bathymetry. So you should have now it's changing. Before we were working on Polygon Island, now we're working on Boracay. So we change, it's 51 PUP. So it's the other satellite image, okay? We switch a bit the area for fun. You should have the Boracay 20-meter filtered data. So this is data set that I prepared for you, okay? And you should have code mbathy, that's the folder, and code bathymetry-demo.py, that's the Python script, okay? You should have all those 4 elements. Yeah? So we start by, on Spider, you have a tool at the top which is called Project. I'm gonna switch. So here you have project, okay? You want to create a new project. Here you can select the position of your folder. I strongly suggest that you keep on C. If you have external disk, keep on the C. Okay? So mine is here, Bathy Demo. That's my project name. Okay? When you select it, it's going to ask for a project name. So you name it the project as you want, and then you put create. And you should have a folder that is being created at the space you selected. So mine is document. So you should have all Bathy Demo and inside the name of your project that you've created. You all have that? So go on your file explorer and find this CopPhil demo. And here, you should have by default, because it's a Python project, you should all have this folder. And then can you copy paste the folder embassy and the Python script? Inside, yes. And when it's done, you should be able to confirm, because on your Spider, you have the name of your project, and inside you have the folder and the Python script. All good? Yeah? You have passed all your files? Have you created your project? Yeah? Oh, you don't have it. Can you have this one? Or you don't have file?
Yeah.
Where are these two books? That's
This one.
yes. So project here, you created project, new project, the folder. Projects, new projects. You have already an open project?
No.
So here you need to select where you want the project file. So here you create, as I showed you, the folder.
And this one.
So this one is the project you created?
We have
No, you need to create a project folder, especially for Spider now. Okay. So this is what I have. So for me, my folder, project folder is Bathy demo, and then I have project name later. So here you need to create a new folder. Be good? Yes. So yes, good. Very good. Aha. So here, this should be inside Bathy demo, because you see here you have just Bathy demo.
Oh.
And now it's okay. So you have, so this is okay? Where is your, this one, right? So now you see, location is bathymetry, project name bathymetry, okay? So you create, and now you need to go in your File Explorer and open this file. So you know it's desktop bathymetry. Can you go in desktop in bathymetry? So it should be on your file system. You have desktop bathymetry. So we all good? Okay. So desktop. It's there. So you open it, and you double click and open it. Bathymetry again. Okay, now you go to your file and you copy embassy and bathymetry demo there inside. Okay. So when you have your project created, let's go back to the slides. We're going to install the package that we need to run the bathymetry module. Okay. By default, Spider has some usual package, Python package, for example, NumPy, mathematics, etc. But specifically for us, we need extra package. So how we do that? You go on Spider, and the way it's organized, you should have first your project here. Then you have the code from the Python script. Here you have some variables and picture plotting. And here in console, be sure that you are in console and not history, you have something when you can type. You all have this. Yes? And this is where we're going to have our import. So, because I show you, don't run it. Here, if I run my bathymetry demo, I'm going to have an error because he cannot find the module GeoPandas. So that's why we need to do this manual installation, okay? So with me, you're gonna do pip install GeoPandas. Don't forget the S after panda. And enter.
It should be inside bathymetry. Okay, and now if you really go to Spider, you should see what's inside there.
You ready? No error message?
Yeah,
No module pip, oh my god.
yeah.
You install Spider with no dependency. So let me check something. That's bad news, but we can always go to the interpreter. So let's try, instead of pip install, try to do, let me check, conda install pip, or no, conda install GeoPandas first. And if that's working, we're going to stay with conda. Conda, C-O-N-D-A. Conda install GeoPandas. Yes, try. You should have conda by the slider.
So for you, so again, you've done your pip install, GeoPandas.
Oh,
Yeah, you should be time. Yeah, and a pip.
it's like,
Install GeoPandas. You know, this one, GeoPandas, so this one. Install space, GeoPandas. Panda. The Panda is working. It's looking, it might be good news. Is it good news? It's getting sometimes. Is it working for you?
yeah, I did one.
No, here, after S, or after the S, enter. No module of it. We're going to try Panda. Okay, and now. I need to restart. So, how do you understand? Restart now. And now try to pip install GeoPandas. So for me, every time I say pip, you have conda. With conda, you could say conda install pip if you want. Okay? For you?
Yeah.
Okay, so you say you might restart the kernel. So what I suggest is either you right click on Python console or on the option on the right side. Yes. Restart kernel. Like that, it's going to apply the modification you have.
Yeah,
You need to restart the kernel, restart the kernel already starting. So try Panda install GeoPanda. You. Yeah, enter. You got it sometimes, so it should work. For the others. Collecting. So,
Okay. So we need to do that for, I'll show you a picture. So GeoPandas you have. Now you need X-array and Rio array. Same Panda install. And you need to make one after the other. Don't try to put everything in one. You're going to blow up your computer. X-array. Let me know when you have all the 3 packages installed. Okay, so it worked. See, done. Up, downloading, it's done. Okay, so now you can do X array and Rio array. Panda install. Okay, just like the same. Don't forget to restart your kernel after each install to apply the modification. And then we're going to start with the code. No, Rio array. So you had X array and then Rio X array. All good? You have restarted your kernel? So if all your Conda install are done, it finished running? It's still going? Okay, let's go 2 more minutes. Conda is a bit more slower than P. That's why we usually use.
Are they prompts?
are they prompts?
I think the question is, are they command line?
Oh, yes. What you type in here is command lines. So here we're working on Spider in a virtual Linux environment, specifically for Python. Okay? If you're working on a Linux machine where you have Python directly installed, you look at Python and you have a console that is disappearing, everything that you are typing here, you can type it directly there on your Linux machine. It's just a user-friendly Linux machine that we are working with Spider. Okay? All good? All good? We all good? So back to Spider. So you have the bathymetry demo.py that is open on your typing console in your developing environment. You have it open. So as you can see here, I have B2, B3, and SCL. You see it?
Yeah.
Here in green, it's a path. So you need to copy paste the path of the GP2 file. Okay? So you need B2 10 meter GP2, B3 10 meter GP2000, and the SCL 20 meter GP2000. No space in your path please be careful. No space. And you see it's a backslash. So when you, depending on how you paste it, you can have the other one. So it's on the folder that you have downloaded. Go to the folder, copy file as path, and you should have it. So you have already the location of your file? Where is the PUP? So we're working with PUP, yeah, right? PUP value. Remember at the beginning we saw where the 20 meters were and 10 meters. So yes, 10 meters. And you want first is B2. Yes, this one, and you want the path for the band. So the whole path. So here. See there, you have the whole path that is being done, okay? Or you can make here and copy as path. You have the path of everything, okay? You have your path. Yeah, and you can do your backslash. You see,
Mark that time.
you can do your video straight over. Yeah. You have your path.
This one.
Image, yeah. PUP, image. We want the 10 meter B2, 10 meter B2, or is B2?
Yeah,
So you're not going to see it, it's in the Twitter, so you need to make it a list. A list, yeah. So you want B2, GB2000, you want the path to that file, and you need to copy in the Python script.
I need to place it in my C drive.
Yeah, it's okay.
I can't.
Yeah, no space.
Yeah.
No space, so it's not gonna work.
So
So here you're good. You just have a problem at the beginning and you need to change all the slash. Back. So it should be in green and here it's green. You have a problem with your string parameters. Goody? Oh. Yeah, be careful, you see your slash, they're all in the wrong size. Here you can remove the first and the second one. And you can add the double slash at the end of your file, or at the end of the string. You need one, and the other at the end. Go. So you see it's just one here. Okay, same here, just one. Yeah, and you need all your slash in the other side. You see mine, I slash in this direction here to change all your slash. You good? Slash. Give the slash check, but I think your slash at the time. Your slash should be done back. Yeah, the other one. You have space. Be careful if you have space. It's not going to work. No space. You have the files? B2, B3, and then SCL, and SCL is in the 20 meter folder. Okay? So do you know what SCL is? Any idea? It's a scene classification. By default, when we create the bottom of atmosphere data, we create a rough classification of the image with vegetation, building, water. It's really a rough classification. But in our case, it's going to be really useful to mask out the land and mask out the clouds. Because unfortunately, on the PUP image you have some clouds. Don't have any space in your folder password. Yeah. And again.
let's see, and slash. Good. I just waiting to change. Are we good? Yes, it looks like you have your space, data, you have PUP, B2, B3 left. Ready. Good. You have all your passed? What have you done? Trying to run something. It's okay. It's here that you need to change. Here you copy, you see, in green, here. This is my path. You see, project against copy. This is the path of my file. You need to put the path of your file. Understand? Here. You see here, B2, I have the path of my, it's my B2 file. You need to put yours. So the path that you made here, you should be there. Look. You access your, okay, the folder. This is the access. Can you copy the path? What is the path of the file? The old path. How do you do it? You know? On map, the path. I need C and the old way to access the files. Look, in my spider, here, you know, you need to tell Python to go in the L20 folder to look for this file. So you need to copy not. Yeah, you can look. So you see here, it's the old file. You need to copy the old path. No one uses Mac here, so I don't know how this works.
We copy to where to the folder or to Spider.
On Spider, you need to put, so Macintosh uses CD, what is the disk? No. So you need the old, you need to see, for example, C, user, draw, desktop, CopPhil Benthic. You need to access everything. You see here, I have all the folder where my file is. See what I mean? So this is what you need to provide in fast. I'm sorry you have a Mac. I don't know how you can access.
I bring them up. I agree that I bring this bring the
If you have a Microsoft, yes. You have all your parts?
Yes.
For you too? Yes? Okay. So I'm going to launch them on this and you're going to work something different. Okay?
So, once you have all your paths, I'm going to quickly go with you for the rest of the parameters, but then we're going to be able to run it. So here we're going to call the different pre-processing. We're going to say we want to work with B2, B3, okay? This is the prepare the mask to mask out the land, to mask out the cloud. Here we initiate the bathymetry, and there we do the calibration, and here we grab the result, okay? In step 8, this is where you need to change parameters again. Here you need to put the file where you want to store your TIFF, okay? So the result of the bathymetry will be a raster file, as we see, okay? We saw that Sentinel-2 is GP2000. For us, we're going to save as TIFF. So you select an output folder in your Windows machine, okay? You create an output folder, you take the path, and then you add the file name that you want, .tiff, okay? Is it clear? Yeah? Okay, for you. you're going to work differently. Okay, you're going to go in this address. Try to go on copphil.gov.com API. Can you go there? On Google, on Internet. Try to go there. So you have your output file, right? And then this is for the figure how you want to save it. So it's .png. Download. So maybe put a different name, okay? Here and then there's a figure, for example, or here bathymetry. The first one will be your bathymetry maps, and this one will be the figures of the calculation and all the stats. Okay? We good there? No space? We good? So be careful, this is a PNG, not a TIFF. Yes?
Single code.
Single or double, Python can manage the two.
Okay.
Okay, so this is for writing path, it's okay. Be good?
Another. You don't have at the beginning and you don't have at the end.
Okay, so now extend it so that a bit more in the middle, because now you don't need to change the code anymore. Yeah, it's a bit long, but should be helpful. Okay. All right, to run the model. Okay, that's right. It's going to tell you if you have a mistake. Yeah. And you can extend here because it's going to run here. So you haven't changed. Oh, you haven't changed this one. Yes, so I'm going to go with you one by one. Okay. So here is the path of the Boracay 20 meters into data. It's the geodesic you have in the file to download it. Sorry, my bad. So another thing that you need to change up is the first one, in situ data. So you see, if you go at the end, is the file is named STV empirical 20 meter improved geodesy. So this file you have in the download of the data, you just need to put the right path, okay? And no space again. You have it?
Very easy.
That is a good sign. Should be able to see it. Okay, come and take my laptop. Up. So this is what you're supposed to have, okay? On Windows, it's working.
Yeah.
Authorize. Okay, close. So how it's working here is the in situ file. Try it out. In situ file, okay? So for me, it's this one, okay?
Okay.
Yeah. Then notification, we don't care. Test. But I'm going to show them to everybody. So you go with someone to see it on Spider, how it works. Because it's going to work on your Windows. You haven't ever heard the error?
Yeah.
What does it say?
Install.
Like, trying to do it. What it told you to do. Yeah, and this is running, right? That's because the Spider you install with no previous package. So that's why. Enter, it's gonna run. So you should not have the same issue. Okay. So run it. It's the green arrow. If you think you're all ready. Ah, yeah. Nope, you're missing one now. Yeah. Run it. Okay, so it asks you to install this package. Because by default, when you don't install, you don't make the install with the default package. Install/c needs to do everything. Yeah, it's all like with the install. You remember the Conda install. You haven't forgot to put Conda install, right?
Yes.
What is it? Okay, so while this is running, okay, because now that you have everything installed, as you see, the error are always going to tell you what's missing. But if we continue this way, because you don't have any default package installed with your Spider, we might spend the rest of the afternoon, all right? So don't hesitate to continue later on and to see if everything is running, okay? And I'm going to show you another way to run it using a cloud interface, which will be the end of the goal of CopPhil, okay? So, the way it's working, so you can back at it because I'm going to just present. So we have a CopPhil service API, all right? The code is exactly the same that you have now on Spider. So I give this access with the demo password, okay, that you're also going to have after the course. Here in situ file is the GeoJSON that you have and you put in situ data line, okay? Here, deep water, this is an option that we are currently developing. So right now we set at empty value. Notification in mail, again, it's a feature that is under development. The goal of this notification is to, once the run is completed, by email, you're going to receive a download path to have the zip with all your results, okay? But this is something that currently is under development. So I just put something random. Dutch, UK. Start date and date. So the bathymetry is doing one date, one bathymetry map, okay? But the way we developed it, because sometimes people need to have multiple maps through times, is we have, just like Copernicus Hub, a start date and an end date. The process is going to look for all image between those two dates, and for each image, provide a bathymetry map, okay? So for the exercise here, I'm just going to put a small one, so 2023, 09, 25, between 2023, 09, 27. So small range, because if we put 20 images, we hit tomorrow again. Here, the tile that I want to process. Where are we working? Do you remember the tile? The tile ID that we want to have here is the one that you have provided. 51, yes, and PUP, yes. You can add several tiles if you want, okay? But we're just gonna work with one. Here is different filter for the calibration. On your script, it's all by default already set, okay? So this is not something you need to change, but here, for NAMRIA and FISA to have access to different parameters, we can change it. Here I put the default value that you have already in your script. So all good, it's all fill, and execute. So this is the command line that is sent to the server, okay? So all this page is prevented you to work on a Linux machine and have to type everything by hand. So this is why it's quite practical. And code, oh, token expired. I need to reconnect, sorry. Up, I need to reauthorize. Up, try it out. I was too long with my explanation. And now we have code 200 for the response, which is a successful run triggered. So it said that my run has been triggered successfully and is giving me an order ID. So this order ID is currently what you need to download the result through the API command line. So it's still a bit tricky because you still need to use the curl connection to the API to get the result. So we are working on this feature to automatically give you the download link, okay, for more facilities. And the result that you have, I downloaded already. It's the results. It's something that looks like this. Here I have the TIFF, that I'm not going to open it because TIFF needs to be open on QGIS. And I have the different GeoJSON and metadata. Okay. As you see, there is no PNG here, what you have in your code. Okay. Because it's just something that's in this version, the PNG, is not something that we need. But the PNG you're going to have, that's going to show up when you do your script, is this one. This is the PNG. When you say save PNG, it's this one. Yeah. Do you remember the first calibration I showed you? How do you think of this one? Yeah, very great. So with this better calibration, I can obtain the TIFF map. So you should have the TIFF map. I don't remember if I put it in your result. So the TIFF for the bathymetry is one band raster. And instead of having reflectance value, I have depth value, okay? So if I open on QGIS, you can see this is my bathymetry maps. I didn't classify the land because I used the SLC band, and SLC band say no land to be classified. But on my version, I didn't have the cloud, so you can see some clouds in my area, okay? But now the cloud has been also disregarded. And I have the bathymetry between 0 and 31 meters. That's my range that has been a bit shifted. And if I zoom, you can see we can see deep water and the different coastal water and all the bathymetry in the area. Okay? So this I have for the whole PUP type. You remember the little area of auxiliary data we had? It was just around Boracay. But I managed to classify the whole time with it. Okay? And with this type of auxiliary data, because it's just color and depth, you can classify the neighboring area as well, okay? Of course, if you go too far, the condition of the sea might change, you have different conditions, so you might need new auxiliary data, okay? But the seabed is not changing very, very fast, except if you have a change, for example, a storm that's going to totally change the environment, or if you have a shift in current, big shift, the different seasons. Up, and again, you remember the tool to see the pixel value. Here I have a depth of 1.89 meter. Okay, and so you can produce this map for any image that you have that you want to select. So either with Spider, with the downloaded image from the Copernicus Hub, or through the cloud platform when you set start date and end date. Okay? You see? So I think we still have some time. Yes. So what I propose to you now, you have several possibilities. Either you want to continue with Spider. Yes.
May I ask some questions?
Yeah, no, of course. Can I just launch them on the exercise and then we can question? Yeah. So you have two possibilities. Either you continue on Spider and you want to debug everything to have a run, or you can also exercise on the data preparation, because on the file of data I shared with you, you have the XYZ raw data, and on QGIS I have the whole process for you to prepare your own data. So you can choose data preparation, or if you want, you can run a bit of QGIS. Okay? So I'll let you select what you want and do some tests. We have still a bit of time, right? Yeah?
Yeah.
Depending on the ground of the water, the colors might change.
Yeah.
Seagrass, sand or so, but in the beginning you said one color equals one depth, and so obviously
it's going to change. It's going to change, and this is the second part of our service, is Benthic Habitat Maps. So on Benthic Habitat, we are classifying the different shallow habitats, and where at the end you will combine the two. The objective is to have for each class its own calibration data. Okay.
So first you would say, okay, this is seagrass, so you have a set that is for bathymetry for seagrass.
For the whole range of depth, yes. Although with this approach, because the change due to the depth is more important than the change due to the seabed, we still have some interesting results. And when we do validate with laminar data, we still have some good validation metrics. But to improve it further, I totally agree, we're going to have to merge the bathymetry and the habitat map. But why we don't present it now, because we're still struggling with the habitat map. In the Philippines, there is a lot of mixed habitats, rocks, seagrass, sand, coral reef, and we're still trying to identify those mixed pixels and those mixed habitats. That's going to make it a lot of subclasses.
And you said you can set a time frame there and say, okay, all these Sentinel images are free, hopefully, in between certain field, and for each of them you make a bathymetry map. Will you then type of average set, or do you think there is a temporal development, or how do you know about that?
The plan, it depends on the usage of the bathymetry maps. If we talk, for example, with the southern area, they don't have the same purpose for the bathymetry map. For some, the bathymetry maps will be used to have calibrated the habitat maps. And for Namibia, it was more to fill the gap between the surveys. So sometimes one map is enough. We could do averages, but the point is not really valid, because when we average, we don't know if a specific event happened. And so we smooth the event. Having one map per date will allow us to see, for example, if a big boat just drag everything up, and in this we're going to see the change. Because even if I put a time range in my process, the calibration will be redone for each image. So it's not going to be the same model applied to everything.
And will this thing that you showed, the service be here ready soon? Because what we could do in our course when we go around is for sure not that people DLGUs do this spider.
So the service is already there. I show how to run it through the API. So it's on the Joby platform for now, but the point would be to have on Pizza. And so the service is there, it's running. We found the GMO this morning, and it was working. But I don't know when the sheet will come. So if this version is working for you, or if you need the next.
We would have simply whatever is there.
For the training, I think you could have to wait really on the platform because in the actual configuration, it's the training for the crowd and the
Yeah,
but they were not allowed to
okay.
use this way.
This test version level.
I don't know if your first training is measured.
End of July.
That is, I mean, it's not on us. For us, we've done everything, it's already, now it's just need to be transferred. So the service as it is, the one I showed now, and the one I'm working on, it's working and it's available. Now we just adding options.
Okay. Yeah, right. After a while, we have to see whether
So what you're working on?
whether we can use it.
The data preparation? Okay, so you open the XYZ data.
I expect that it's,
And I'll show you the previous slide again. See, it's the first one, it's vector, not XYZ. Vector.
Target is good. That's pretty well. So
okay.
Layer.
That's 2 weeks.
And layer, the first one.
really, I don't think
So I see you already have your layer. So now what you need to do. Oh, yes,
yeah.
that's not, yeah, you, this is mine.
No, this is, yeah, this one was the one that said.
You created it,
Yeah. They just.
So if you want some, you can try to make a new
space.
file for the calibration, see if you can do better. And you see now the map instead of mine, you have the clouds and maps.
And what they're saying is we're on that next.
You also have to use the result from the spider. Brilliant. So if you go on spider,
So you're training my.
you have your calibration again, see to be better. Further, so you can do if you want the step,
Yeah.
try to make the whole calibration data and see if you can improve the result. Like that, yeah, better. But it's good news that starting on spider. So good news, they start with the spider and after install, the last install for the install you've done, you have the result. Okay, so you should be quite straightforward to have your bathymetry.
This is where you.
Okay. If you want to see the spider results, I invite you to have a look to the computers. If you want,
Okay.
the people behind you that have managed to run the spider script, if you want to see the results, it's been running.
So basically, you could do that right now already.
Yeah, they just made it.
I mean, you could theoretically do it for vulnerabilities right now, or?
So with the priority, yes, but there is two constraints. Right now, I just have the auxiliary data, but for Boracay Island. So we need other data for calculating the rest. And to know PP, I need, yeah, I need a big computer, because here is, they managed to run it. How long it took for to run the script?
I think less than a minute.
Less than, so let's say 1 minute on one side. For the, I think you have 15, something like that. Sorry, for the whole Philippines, I think you have 15 something like that to cover the whole country.
Ah, okay.
So you have to multiply every time.
Plus, and
Plus the storage, that's the RAM, that's everything. We have problem is how to access it in the results. But yeah, theoretically, I agree. We could
Yeah.
go.
You just do the same, you just need to adjust.
Yeah, the algorithm is running, they managed to get them maps. And now they just want to do some sort of calibration. But the script on spiders anyway.
One last use, parehas tayo no.
Well,
There's like
right now,
symbols.
you would be able to search all your,
So no,
double here, for the expansion.
good one.
Just in case another one is there comes.
Since the.
A map user on
Max, Apple.
Yung.
No, I'm absolutely, I'm a Linux and Windows user for most.
Clear answer.
Yeah,
That's good. I think we should.
I have no idea. The major problem was to copy files fast. I mean,
If you have survey, we have I have Mac, Microsoft, Windows or Linux po from before. Yung machine po. Laptop. Meron po ba kayo? Windows or okay. We upload naman itong course online. So makakapagod ba kayo? Pero we take student tong the same training on Thursday.
Understand?
So, ito sila lang kung sir, tayo nyo siyang makakuha ulit ng time. Pwede din tayo. Not time for dito din. Windows. Windows. You have I think what I just like to do the as we have kasi magdata siya.
Meron po
Windows. May Mac files configurates too. Deploy along sa machine sa government.
mixed. May Windows, may Mac.
I don't know. I mean, what operations or function mo po binibigay ang smart which ang nakikita ko lang kasi sa PILSA is the public relations guys. Like for presentation, iris, photo editing. On the field, ganun din. Kung may questions po kayo, we're almost done. If you want more, sorry, sila ako. More.
Were they doing the data?
You will. Yes.
I
Yes. You want me to do something?
Well, you can give them on these exam challenge. They want to. I'm working. And they're. I'm going to.
So all good? Managed to do some selection with the data? We managed to do some extraction?
I have a question.
Yeah.
So you said that we can still calibrate this one. So
Yeah.
the step 6.
So no, you don't change those ones. What you need to change is the institute data. Okay? So what I had on my slide is how to select and create your own calibration data set. Now you're working with my calibration data set, which is not perfect on purpose. Okay? What you can do now is if you go back to your files, it's the one you downloaded. Yeah. Show me the file you downloaded the data.
This one.
Yes. Here, if you go to Get Institute, here you have the all 6,000 points.
Okay.
This is the all raw data. And from there, you can create your own sub-calibration data and try to see how you can improve the calibration. So you can play around with this one, with the slide, with the selection, sample selection. So be careful. Here you have everything between 300 and even some land data. Okay, so that's why this is really the raw file, and then you can play with it on QGIS to create a new in-situ and see if you can improve a bit my RMS. Okay.
What type of file is the institute data? Points?
So the in-situ data, the raw data I have from NAMRIA, it's XYZ data files, and for the process, we need GeoGZ.
Okay, but it's points and
Yes. Of course. It's vector points data. I only have latitude, longitude, and depth.
okay,
Yeah.
that's what you need.
Absolutely, quite straightforward, yes.
What is your zero?
Zero is, so I'm taking the zero provided by NAMRIA.
Okay.
So the question I didn't ask if it was mean sea level or what which reference that they use.
It is, in some cases, it's very important.
Yeah.
Uh,
No, of course,
But,
that's because sometimes you have.
where the coast is very close
Yeah.
to the sea level, then where is actually.
So that's why sometimes on the calibration we have some anomalous points. That's because sometimes we should some land data. So that's why having the opportunity to play with the raw stellar data that allow them to check all the points that they're using are really below lowest sea level.
Yeah, I'm living with Mount accidents, and so I know this happened.
Yeah. Before, I mean, bathymetry is one of the aspects I'm working on with audience, but our major topic is coastline extraction and shoreline time series. And we know that, yeah, every country has different dating references, and sometimes it's really tricky to map them. Yeah. But we have been contacting now because they also need for boundary between countries, especially when we have an estuary. We know that they are fighting in countries, so they're fighting, oh, this sandbar is mine, so the boundary is out there. So we're trying to start to find some average sea level with them and see how we can support them.
Yeah.
It's really working with shoreline is really interesting. I spent 5 years on it. Really great.
I try to use this type of data from Copernicus, and there is so wrong.
Yeah, that's why we have to develop our own data. Yeah. And now we managed last December we got presented at the UK Space Agency. Because for our process initially, we needed very low resolution, a very high resolution DTM for the beach, and some wave parameters and stuff like that. And we've been working with Stats and Southampton University. And now we have Southampton, okay. And now we have a whole process that is totally independent of local auxiliary data. And because we had when we worked on Ghana, Cameroon, photos and everything, then we lack of auxiliary data with really challenging. So now we have a process that can be applied all around the world. And now we just found really this. Yeah.
Because I talked to the ASC guys, and they are trying to work on it.
It's just that you know.
So we have
Actually, they didn't do it themselves, it was the University of Vienna.
actually we have an application already, coastal change, something like that.
Do you have a partner?
Yeah. And because we have already everything there.
Yes, I will take the opportunity. So we can continue the discussion. I will just close the session because we are recording for the other participants. So thank you for being here, and I hope this was useful. So we'll be having the similar duplicated session this Thursday. So if some of your colleagues wants to join, they can contact us. As you see, we had 20 people today, and so we may have some, unfortunately, but we might have some more space on Thursday. So following this practical training, there will be another one in Benthic, which is planned just before the Philippine Space Week, so between the 7th to the 8th of August. So you'll be invited to this. And I just want to conclude again back on this CopPhil Digital Campus, where you can find all the materials for the training course on Benthic, but also on the other courses, as Monica mentioned at the beginning. And if you want to get some certification at the end of these courses, you have to go to this CopPhil Digital Campus and take the quiz. So for each session, there's a few questions that you have to answer to validate the course, and then this will allow you to get some certificates at the end of the training. I think that's it. Yeah. So thank you very much, and we hope you had a great and interesting training today. Thank you.
Thank you.
Okay.
You'll see if you want to stay, or you want to catch. I don't know. Then I guess we're going to have the
Okay.
Para lang pang telephone. But anyway,